Greetings, curious minds. Today we embark on a journey into the cutting-edge realm of technology, where computing meets the bizarre world of quantum mechanics. Welcome to the rise of quantum computing. In this video, we'll unravel the enigmatic world of quantum computing, dive into its core principles, envision its potential applications, and dissect how it diverges from classical computing. Quantum mechanics. Primer. To understand quantum computing, we first need a crash course in quantum mechanics. Picture a realm where particles exist in multiple states at once. This is superposition. And when these particles become intertwined, no matter the distance between them, it's entanglement. Quantum bits, or qubits, leverage these quantum properties to process information in ways that defy classical logic. The quantum versus classical divide. Now, let's contrast quantum computing with its classical counterpart. Classical computers use bits that can be either 0 or 1, like a light switch. Quantum computers, on the other hand, harness qubits, which can exist as 0, 1, or both simultaneously. This allows quantum computers to perform multiple calculations in parallel, unlocking a realm of computational power that classical systems could only dream of. Unleashing quantum potential. So what's the buzz about quantum computing's potential applications? Hold on to your hats. Quantum computing can transform industries like cryptography, optimizing complex systems, simulating molecular interactions for drug discovery, and revolutionizing artificial intelligence. With quantum supremacy, the point at which quantum computers outpace classical ones, looming, we're on the cusp of solving problems that were once inconceivable. Peering into the quantum future. But what lies beyond? As quantum computing advances, we stand at the brink of an astonishing era. Imagine encrypted communication networks impervious to hacking, personalized medicine tailored to your DNA, and climate models that predict environmental shifts with unparalleled precision. The possibilities are as vast as the cosmos itself. Conclusion. As we conclude our exploration of the rise of quantum computing, we're left in awe of the boundless potential this field holds. From its mind-bending principles to its game-changing applications, quantum computing is propelling us into a future where the impossible becomes reality. So, let's embrace the quantum revolution, support its advancement, and dare to dream big.